Bull is a node library that implements queues on top of Redis. A queue is a mechanism that allows you to centrally manage and distribute workloads across your application. To understand this, you need to understand some of the challenges that we run into when running a microservice architecture. So generally when you run your app in a microservice architecture, you have different Node.js applications running across different servers or different regions. And let's say you have a piece of work or a task that is running on a particular application, and for whatever reason the application crashes, or the hardware, due to hardware failure or network failure or whatever reason, there is no automatic way to detect that failure and reinstate the task or allocate the task to another processor. So this is where a queue system can be really handy. In a queue, you define a queue, and then you have producers, which are nothing but applications that add jobs to the queue, and then you have consumers, which are nothing but processors that take that job and process them. So for whatever reason, if one of the application goes down, then the task is automatically allocated to another processor and the job runs all over again. So this ensures reliability, and this is where a queue system can really come in handy. So in this video, let's look at how to set up the Bull queue, and we'll look at a few examples and understand what options are offered by Bull to control the flow of your task or control the failover options and all that stuff. So first we need to start a Redis server. As I mentioned earlier, Bull implements a queue system on top of Redis. So first we need to create a Redis server. I'm going to use Docker to create the Redis server, but if you don't understand Docker, maybe you can watch some other video and come back to this one. Docker makes it really convenient to spin up and bring down the servers. So we can create a Redis server using this command, docker run command, and I'm just going to quickly explain this command. So first we specify the port forwarding. So Redis by default runs on 6379 port, and we're going to run run Redis on the same port on our machine, and then we specify the name for the container, and we want to run this in detached mode, so we provide -d flag, and then we provide the image name that we use to create this container, and then we say append only yes. That is used to persist data. We can ignore append only for now, and then we just need to provide the password for the server, which is 123456. If you hit enter, then I need to give in my perfect. So it created this container, and this is the container ID. Now that we have Redis server running, let's get on with the Bull queue implementation. So here I have a new Node.js project, and I'm going to first install the two dependencies, which is bull and .env to load environment variables. Once these two are installed, I'm going to create a .env file with the Redis details, which is the host, port, and password. Generally, it's recommended to pass sensitive information through environment variables and not recommended to hard code in the code. So I'm passing these values through environment variable. Okay. And I'm also going to create a Git repository. And I'm going to create a dedicated branch for each demonstration. So for demo 1, you'll have a branch, and for demo 2, you'll have a different branch, and so on and so forth. So for the first demonstration, I'm going to create demo 1 branch. You'll see at the bottom left corner from master, now it switches to git checkout /b demo1. What it does is, if demo1 branch doesn't exist, it creates that new branch and also checks out that branch. So if you hit enter, you will see that on the bottom left corner it changed to demo1. Okay. I'm also going to create index.js file to write the code. All right. In the first example, we're going to look at a very basic demonstration. So we'll implement a very simple Bull queue. First, we need to import bull and .env, and then we need to run .env.config to load the environment variables. And then we create Redis options with the Redis details. The Bull queue is going to get connected to the Redis server, so we create this Redis options, and then we define the queue. And in this case, I'm just calling the queue as burger queue to keep it simple. And then we pass the Redis options. And burger queue is nothing but an object created using the class bull, which we imported earlier. And then we need to register the processor. So registering processor is nothing but registering the consumer that we discussed earlier. So this function is going to get executed when a new job is added to the burger queue. All right. And this is a very straightforward function. You just logging some data to the console. So we first log preparing the burger, and after 4 seconds, we just log that burger is ready, and we need to call the done function to indicate that this process is finished. And finally, let's add a new job to the queue, and we can do that by calling the add method. And I'm also passing in some information to this job, which is the bun, cheese, and some toppings. Again, this is a really basic example. So when we run this, this piece of code adds this job to the burger queue, and this function gets executed. So let's run it. First, let me save it, and if I run it, you can see it's preparing the burger, and after 4 seconds, the burger is ready. So it works fine. In the previous demonstration, although the job worked fine, wouldn't it be nice if you can visualize the jobs in the queue and their status, and how many jobs are in the queue and all that stuff? So there is a way to visualize it. We can use bull.js library to achieve that, and this is a free repository that you can use, and it not only offers a dashboard, it does offer some capability to reinstate failed jobs, and a few other stuff that we'll discuss later in this video. First, let's see how to implement the dashboard using this bull.js library. Here is how you can implement the bull dashboard using bull.js library. And I created a new Node.js project here, and I'm not going to get too much into the details. So we just installed the bull.js packages, dependencies, and in the index.js file, we just create Redis options, and we just pass the list of queues that we want to visualize on the bull dashboard as an array, and then we create an express server to create a route that we can open in the browser and visualize the bull board. So I am running this project in a separate window, and you get this URL that you can open directly in the browser to visualize the bull queue. So this is how it looks. So when you open the link, you will see bull dashboard on the top, and you will see the list of queues available. As of now, we just have one queue, which is burger, and these are the different possible statuses of a job, which we'll discuss later when we discuss about the life cycle of the job. But yeah, so we have only one job that we ran earlier, which is in completed status. And if you click on burger, you will see different tabs over here, which indicates the jobs that are present in each of these statuses. So we only have one job that we completed earlier, and we have the data that we passed, and we have options and logs. So again, we'll get into these as we dwell deeper in this video. But yeah, so we can use bull dashboard to visualize these jobs. I will share this code in the description box, and you can explore this repository and figure out how this is implemented. But it's really straightforward. It's just 40 lines of code, and it's really simple. Now let's move on to the second example. Before that, first let's commit these changes and create a new branch. That's it, we are on the second branch. I've added dashboard to the right so that it's easy to visualize when we run the job. In this example, let's look at how we can add logs that we can visualize from the bull dashboard, and also how we can update the progress of the job when we run it and visualize from the bull dashboard. So first I need to modify this processor, the consumer function. Set timeout, although it works, it's a really clunky way to implement. So I'm going to convert this into an async function and promisify set timeout to create a sleep function that I can use in async function. So let's import promisify from util and then create sleep. Perfect. I'm going to create 5 steps to create the burger. So these are the 5 steps: grill the patty, toast the buns, add toppings, and I just want to add some more complexity to this job. So after each step, we're going to await for a second before we move on to the next step. Okay. And after all the steps are finished, we call the done function. And let's wrap this in try catch block because it's an async function. And if there is an error, you can catch it by calling the done function with error. That's it. So let's run it. We should see an active job here. Awesome. So if you look at the logs, you can see okay, so now the job is completed, and you can see that the log statements are displayed to the console, displayed in the bull dashboard. And we use payload.log to log the statements to the bull dashboard, and we can use payload.progress to indicate the progress of the job. Again, I think it finished a little too quickly. I wanted to see the progress being increased from 20% to 40% and so on and so forth. So I'll change the time period to 5 seconds for each step. And finally, once everything is finished, awesome. So let's run this again. If we go to the active tab, we should see a new job. If we go to the logs, you can see the progress is 20%, and after 5 seconds you will see the next log to the dashboard, which is add toppings. Perfect. So again, by default it's paused, that's why you didn't see it, but yeah, you can see after assemble it's 80%, and once everything is finished, burger is ready. It's once it's finished, it moves on to the completed queue, completed status. And if you look at the logs, you will see all the logs over here, and the progress is 100%. So this is how you can add logs that you can visualize from the bull dashboard, and add progress that helps you troubleshoot or identify the progress of jobs. Now let's look at a job's lifecycle. These are the different statuses that a job can hold during its lifecycle. So when a job is newly added, it either goes into a wait status or delayed status, depending on whether it's invoked immediately or if the job is scheduled at some point in the future. Yes, you can also schedule a job in the future and you don't have to invoke it right away. And from the wait status, if you have some kind of throttling implemented, then the job stays in the wait status for a while and then goes on to active status. And if there is no throttling, the job immediately moves from wait to active status. And from active status, once the job is completed processing, it moves on to completed status. And if there is an error, it moves on to the failed status. And if you have some kind of retry options set, which we'll discuss later in this video, if the retry options are specified, the job tries to retry again, and again it goes into the delayed status and delayed to active. And if the retry is successful, it moves on to the completed status. If not, again it repeats this cycle. And once the job is completed, it's finished. So these are the 5 different states the job can hold: wait, delayed, active, completed, or failed. Alright, now let's move on to the next example, and before that let's commit these changes and create a new branch. In this example, let's look at different options that we can pass when defining the queue. So by default we have passed Redis options, but there are some other options that we can pass to customize how the queue is executed. So I'm going to change this to queue options and pass in over here. Let's look at the documentation. So this is the official documentation, and these are the different options that we can pass when defining the queue. And by default we need to pass the Redis options because bull queue connects with Redis, so Redis options are mandatory. But there are some other options that we can pass, like limiter, and a limiter is used to throttle or rate limit your function execution. And prefix, so all the jobs that are stored on Redis using a prefix, which is bull by default. But if you want to change it, you can use the prefix option. And default job options, advanced settings, and all that stuff. So again, I haven't used all these settings, but in this example we're going to look at rate limiter and see how we can throttle the functions. But if you want to know more about all the possible options, I'll leave a link to this in the description box, and you can explore all these options. So if you want to throttle the function, you can pass in a limit option, and limit takes in 2 keys: max and duration. Duration is specified in milliseconds. So if we specify max as 1 and duration as 5000, that means this queue only executes one job every 5 seconds. And let's change this to 10 to clearly visualize how this works. So with this setting, now the queue should only process one job every 10 seconds. And keep in mind that these queue options are only passed when defining the queue. All right. And then instead of adding a single job to the queue, let's add 10 jobs to the queue. So we are defining 10 jobs again with the same payload and adding all the jobs to the queue at once. So let's run it. And as you can see in the queue, it's running the first job and all the other jobs are currently in waiting status. And if you look at the job that's running, again, it takes 5 seconds to run. It has 5 steps to execute. And yeah, let's wait for it. 80% finished. So now the burger is finished, completed. Now the next one takes over. So this is how we can use limit options to throttle the function execution. In this example, let's look at what happens when the job processing fails. As always, let's commit these changes and create a new branch. Let's give step 2 a 25% chance of failure. So 25% of the time the toast gets burnt and the job fails. So what I want to see is what happens when the job fails at step 2 and how it would reflect in the logs. So we need to specify the retry options. We can specify retry options when we add the job to the queue. There are several other options which we'll discuss in the future examples. But for now, let's put attempts to 3. That means the job tries to retry 3 times when there is an error. Okay, now let's run it. Again, I've added 10 jobs to the queue and I also deleted the existing job so that we can start fresh. So let's run this. So the third job failed on the first attempt. And if you look at the logs, whenever the job fails, you can see the logs start from the beginning, right? So that means whenever there's an error, the job tries to run again, the function runs again from the beginning and all the steps are executed again, right? So the function, what I'm trying to say is whenever there's an error, the job runs again. So it's important that you design your functions in an idempotent way. So what I mean by idempotent is that no matter how many times we run the job, it should produce the same side effects. And the job can fail at step 2, step 3, or at any step, but when it's executing again, it should produce the same result. So the job failing at a particular step shouldn't have any side effects. As always, before moving on to the next example, let's commit these changes and create a new branch. In this example, let's look at some events that bullqueue offers to listen to in your Node application and take actions if required. For example, you want to know when the job is completed or when the job has failed. So you can listen to these events and get notified or take some action in your Node application. So I'm going to keep this as it is. I'm going to put 25% failure as we did in the previous example. And while adding jobs to the queue, I'm going to add another option which is job ID. Now we can add events. We can add a listener to failed event and completed event and see which burgers have completed and which ones have failed. So here I added an event when the job is completed, just logging to the console that the burger ID with the ID has completed. And I'm going to repeat this for failed event and just log to the console that this burger failed. And I'm going to add 10 jobs as always. And let's run this and see what happens. You can see burger 1 failed. So burger 3 completed successfully. So yeah, I just wanted to demonstrate that you have these events that you can listen to and take action if required, or you can just log to the console, or if you have any requirement where you need to listen to these events, you can do so. Here are the list of events. Again, I leave a link to this in the description box. You can check out all these different events, and bullqueue supports event listeners to all these events. Now, one thing to keep in mind is that you can either listen to a local event or a global event. So what I mean by local event is, in the previous example, we were listening to a processor that is registered on that same Node.js application. But in a microservice architecture, you could have 10 different instances, or n number of instances of your application running. And if you have multiple processors that are registered to the same queue and you want to listen to all those processors, then you can set this global flag. So if you set to global flag, then you're listening to all the processors that are registered to this queue, no matter which application generates them. So if you want to just listen locally, you can just listen to the plain event. But if you want to listen globally, just append global, just prefix global before the event. In this example, let's see how to add a recurring job, and we'll look at a few other options that we can pass while adding the job to the queue. And as always, let's commit these changes and create a new branch. First, I'm going to delete these event listeners, and then I'm just going to add a single job to the queue because we're going to add a recurring job, right? So we can just add a single job, and we can pass the recurring options while adding the job using the option repeat. And inside repeat, it takes a key called cron, and inside this cron we can specify the schedule in cron job syntax. So this is how we specify the syntax of a cron job. So let's look at some examples. So this is the cron job syntax. So if you want to add a job that runs every 10 seconds, right? So this is how you do it. So this job runs every 10 seconds. If you want to run the job every minute, this is how you do it. This runs every minute on the first second. But if you want to run the job every hour on 15th minute, then this is how you do it. But if you want to run the job every 5 minutes, then this is how you do it. So again, you can check out the syntax. It's really straightforward. Let's add a job to the queue that runs every minute on, let's say, the 10th second. Let's run this and see how this works. If you look at the queue, you can see by default it stays in the delayed status, and when it's triggered, it goes back to active or waiting status. So this is set to trigger at the 6th minute 10th second. So let's wait for that. Awesome. So when it's triggered, it moves into the active status, and now the job is executed. You can see the first, it failed for 2 attempts, and if it fails for the 3rd attempt, which it did, it gets pushed to the failed status. And in the failed status, you can either clean the jobs or retry it. Again, we have set to fail, we've set a 20% chance of 25% chance of failure, right? So that is the reason it got, pushed to the failed status. So you can delete this, and again, it's still, you have a job sitting in the delayed status. Again, the next job will be triggered on the 7th minute 10 second, and once this is pushed to the queue, another job is triggered at the 8th minute 10 seconds. So this is how you add a recurring job to the queue. So these are all the options that you can pass while adding the job to the queue. So let's look at these really quick. First one is a priority. So again, if you're adding jobs to the queue, you can set a priority to the job. The highest one, the smaller the value, the higher the precedence. So if you want, you can add jobs with, let's say, priority 10 by default, and if you want certain jobs to take higher precedence, you can set the priority to 1 or something lower than 10. So that's how priority works. And delay, you can add a delay. It's pretty self-explanatory. You can add a delay to the job before it gets executed. And attempts, we already looked at attempts. This indicates how many times the job is supposed to retry when there's an error. And repeat, we also looked at repeat. This is used to schedule a recurring job. And back off, again, so back off is the amount of time the job needs to wait before it retries again. And the next one is LIFO. So generally, when the jobs are, the order of execution is LIFO by default. So the order of execution is last in, first out. But if you want to change it to FIFO, you can set it to false. So if you set it to false, then the job that got added last in the queue gets executed first. So again, it's up to you. It depends on your requirement. And we also looked at job ID. Again, we looked at job ID when we looked at events. Again, there are remove on completed. Yeah, this is to delete the job from the queue when it's completed. Remove on fail. Again, it's the same thing. You want to delete the job when it's failed. I think we already looked at a lot of these, and the others are also pretty self-explanatory. So again, you can check out this documentation. I leave a link for this in the description box. That's it for this video. Let me know in the comment section if I had missed something. And if you want me to cover some other topic, feel free to share your feedback. Thank you. Bye.